probability today. It's the last topic of our TSIA Blitz. I wanted to do this one closest to the test because we have not had a probability unit this year. So this one has been a while since you did probability back in geometry. So I wanted to do it closest to the test so it was fresher on your mind because we haven't talked about it together this year. So we're going to start with some basic probability questions. We'll talk a little bit then about the difference of and or when we're doing compound probability, and then we'll move on to the back. But just a quick reminder with our basic probability, when you are finding probability of an event, we use the notation. Let me get my pin number here. And you'll see like the probability of event A, okay? Or you may see the probability of event B. The events can be named whatever letters we want to name them. But when we start talking about multiple events, there are compound probability formulas. Now, I'm not going to expect you to remember these formulas. It may be better to just kind of logic through these first couple problems. But when in this first one, for instance, it's talking about there's 20 kids in an Algebra 2 class. Okay, so 20 total students. 10 of them play basketball, 13 of them play baseball. There are 4 who play neither. What is the probability of the student chosen at random plays both baseball and basketball? So here, this is a formula we could use for this would be, I'm going to put it up at the top here and kind of walk you through this. It says that if you're looking for the probability of A or B, you'd find the probability of A, add it to the probability of B, but then you have to subtract the probability of A and B. Okay, we're going to talk more about and or in a little bit. Okay, but this formula can also be rearranged. Okay, so for instance, in this question, they're wanting us to find the probability that the person in the class plays both baseball and basketball. Okay, so that's actually this piece here that we're missing that we're trying to find. So I can rearrange this equation to get this piece by itself. Okay, here it's being subtracted. So if I moved it to the other side of the equation, it would be by addition, right? I could add that over to the other side. And then this or probability, I could subtract to the other side. So what would happen is that those would end up switching spots. So you could rearrange this so that it's the probability of A and B equals the probability of A plus the probability of B minus the probability of A or B. See how those just ended up switching places? Okay, so in this case, it's the and that I'm trying to solve for in number 1. So I want the probability that they play both. That's an and. Okay, so I'm trying to find this piece here. So I'm going to do this. I'm going to call 10 of the players that play basketball. I'm going to call that event A. They play basketball. Okay, and 13 of them play baseball. I'm going to call that event B. Okay, and there are 20 total. So the probability that they play basketball is 10 out of how many are in the class? So 10 out of 20 that they play basketball. Okay, and then the probability that they play baseball says 13 of them play baseball out of the 20. But then I have to subtract the probability of A or B if they play basketball or baseball. So to get that part, I have to think a little bit because they tell me up here there's 4 students who play neither. So out of 20 students, if 4 of them play neither, how many does that leave? Going to leave 16 play at least one of the sports. Okay, so that's this piece here. Because 4 of them play nothing, that leaves 16 that play at least one. So there's 16 out of 20 that play one or the other, right? So if I calculate this, these are all out of 20. So when you're adding and subtracting fractions, remember you can just keep the denominator as like the denominator needs to be a common denominator, which it is. So really I'm just doing 10 plus 13 minus 16. And what does that come out to? Ten plus 13 is 23. 23 minus 16 is 7, right? So there's a 7 in 20 probability that the student plays baseball or basketball and baseball. Okay, now you may not have known this notation, and I don't expect you to know it after one example, but I just want you to help you see that, okay, 10 play basketball and 13 play baseball, so that's 23. But that's more than are in the class. So obviously there's some overlap happening because there's only 20 kids in the class. So 23 can't play sports if there's only 20. So that there is some double counting happening. So then when you take away the 4 that don't play anything, there's only 16 that play something. And so it's the difference in the 23 and the 16 that gives us that 7. So there are the overlap is 7. So there are 7 that were being double counted because they play both. Does that make sense? Oh, okay. Now again, you may not need to remember the formula, but if you can kind of think your way through that, be like, well, 4 don't play, so there's only 16. So it definitely can't be 23. The difference between 16 and 23 is 7. So 7 out of the 20 play both. That would be the probability that one at random, 7 out of 20. Okay, let's see if we can think through this one. I think this one's a little easier to think through. It's talking about a spinner with 14 equal areas. So picture a circle, like a pie chart, where all of the pieces are equal in area. There's 14 of them. They're numbered 1 through 14. Okay, if the spinner is spun one time, what is the probability that the result is a multiple of 4 or a multiple of 6? I can use this same formula that we talked about up here. This one says or. It says a multiple of 4 or a multiple of 6. Okay, so I'm actually looking for this or piece up here. So I'd use this top one. So I'm going to take the probability of getting a multiple of 4 plus the probability of getting a multiple of 6 minus the probability of both. The number we land on is both a multiple of 4 and 6. So the first thing I'm going to do is I'm going to list out the multiples. Okay, so the multiples of 4. Okay, this just means count by 4s. So 4, 8, 12. And that's the last one I can list because we're only going up to 14. Okay, so 4, 8, and 12 are multiples of 4. Okay, the multiples of 6 would be 6 and 12. So far, so good? Okay, a multiple of 4, that's 4, 8, and 12. So there are 3 of them. Do y'all agree? The multiples of 6 are 6 and 12. So there's 2 of them. So if we take the probability of A plus the probability of B and subtract the probability of both, we're going to get the probability of one or the other. So there's a 3 in 14 chance and a 2 in 14 chance. But are any of those numbers both a multiple of A and B? Were any of those numbers we listed duplicated? There's one. Is there in those, if you look at those lists, are any of them the same? The 12. There's one that is the same. There's one that is both a multiple of 4 and a multiple of 6. 12. So there's one possibility that's being duplicated. So if I calculate that, 3 plus 2 minus 1 is 4. So there's a 4 in 14 chance. And if you can reduce your fraction, you want to reduce it. So that would reduce to 2/7. So there's a 2 in 7 chance that you would land on a multiple of 4 or 6. Okay, you could land on a 4, 6, 8, or 12, and to make this true, those are your favorable outcomes out of your 14 total possible outcomes. Okay. All right. Now, when we get into compound probability, now some of you over here, rather than writing it out as the formula, actually, before I jump ahead, may have just counted. You would have been like, okay, there's 1, 2, 3, 4 different numbers here, right? In my lists. So there's 4 different possibilities and I'm out of 14. So 4 out of 14. So you would have gotten the same thing thinking through it just logically as actually doing the probability formula. Okay, so you don't have to do it as a probability formula always. Sometimes you can just list things out and think through them logically and get the correct answer. Now, when we go to start calculating these compound probabilities, this is when we have separate events happening, multiple events. Okay, the and or the or, okay, are pretty important. Okay, when we see and, okay, in probabilities notation, and is written as what's called an intersection. So the probability of A and B would be written like this. Okay, that notes this symbol here in between the A and B. That's called an intersection. Okay, so you'd be looking for the probability of events A and B intersecting or overlapping, okay, where they're both happening. So this is read as the probability of A and B. And if you have two separate events and you're trying to find the probability of event A happening and event B happening, then you would multiply the individual probabilities to find the chance of both happening. Now, or the probability notation for or looks like this. The probability of A union B. Okay, that symbol is called a union. And this would be read as the probability of A or B. Now, if you've got two separate events, independent events happening, okay, you would find the probability of each of them. And then if you want the probability of A or B happening, you would add the individual probabilities. To find the chance of one happening. One or the other. So in this compound probability example, it says a bag contains 7 red marbles, 8 blue marbles, and 3 green marbles. If 2 marbles are drawn out of the bag, what is the exact probability that both marbles drawn will be blue? Okay, so this is going to be 2 separate events. We're going to draw a marble and then we're going to draw a second marble. Okay, so we have to calculate the probability of each of those separately. And then, because this one is asking us the probability that both marbles are blue, we want the probability of drawing a blue and then drawing a blue again. This is an and. Okay, we want both marbles to be blue. So we're going to end up multiplying these two individual event probabilities. Okay, so first I'm going to list my marbles and get a total. So there are 7 red, 8 blue, 3 green for how many total marbles? 18. So there's 18 total marbles in this bag. Okay, so event A, okay, or your first draw. How many blue are there? When you go to draw from the bag, how many blue were there initially? 8 out of how many in the bag? 18. So your probability of drawing a blue, the first draw, is 8 out of 18. Then event B, oh, I'm misspelling event here. Which is your second draw, is going to look a little different because how many marbles are in the bag now? You've drawn one out. There was 18 to start, but I picked one. So now there's only 17. If the first one that I picked was blue, how many blue are left in the bag? There's only 7 blue ones left. So this event B is dependent on event A already having happened. Okay, so when we do this compound probability, those are things you have to think about. Okay, we already drew a marble out, so now there's only 17, and the first one was blue, so now there's only 7. So there was an 8 and 18 probability of the first draw being blue, and then a 7 and 17 probability of the second one being blue, given that the first one was blue. Okay, so now I want the probability that both of these happen. I have to multiply those individual probabilities. So I have to do my color here. Multiplication of my two probabilities. Now 7 over 17 does not reduce, but I'm actually going to reduce this one 8 over 18. It's easier to reduce now than it will be later. So 8 over 18 will reduce to 4/9. So I'm going to write that one as 4/9 just so my multiplication is easier here. Now when we multiply our fractions, remember you multiply straight across the top and straight across the bottom. So 7 times 4, or 4 times 7, is 28. And 9 times 17 is 153. So there is a 28 out of 153 chance that you would draw 2 marbles and both would be blue. That is the exact probability. We are not going to get that as a decimal and round it. Okay, I think most of you know the difference in exact and to the nearest. Okay, exact just means we do not round. Okay, so if you do your division here and it comes out as a decimal, like a long decimal, and it cuts off, we're not going to approximate and round that. We're going to just leave it as a fraction. Now, if you can divide it and it is a truncated decimal, like 1/4 is 0.25, you can write 0.25. That's exact. Okay, that's not a rounded decimal. Okay, but if it says to the nearest, this tells us we should be rounding. We are finding an approximate answer. Okay, so for instance, had this said find the approximate probability, it would be approximately 0.183. If I divided that, that could be a rounded decimal, but they want the exact, so we leave it as the fraction. Okay, but that's about or approximately 18% chance if we were doing that division. So far, so good? All right, flip it to the back. Now this time we're given a table. So this is probability from a two-way table. So this table is talking about, it says in a class of students, the following table, data table summarizes how many students passed a test and completed the homework due the day of the test. Okay, so we have the number of students that passed the test and completed the homework, passed the test and did not complete the homework, failed the test and did the homework, failed the test and did not do the homework. Okay, so two-way table. So we've got our columns and our rows labeled. Now, this doesn't tell us totals. So out to the sides or under to the sides of your rows or under your columns, it may be helpful to you to write your totals. Okay, so how many total students completed the homework? If I add these two together. (17 plus 5). 17 of them completed it and passed the test. 5 of them completed it and failed the test. So 17 plus 5 is 22 completed the homework. Okay. 2 did not and passed. 3 did not and failed. So 5 total did not complete the homework. Okay, I'm also going to put the totals under here. So the total of people that passed the test, 17 plus 2 is 19. And the total of people that failed the test is 8. And you can see either which way you add this, whether you add this column or you add this row, the total number of students is 27. So 27 students total. We can see the breakdown of if they did the homework or not, and the breakdown of whether they passed the test or not. So we're going to use this information to find these probabilities. What is the probability that the student selected, that a student selected at random passed the test? Okay, so how many total students passed the test? How many total passed the test? We wrote it in. 19 passed the test. Okay, that's what we wrote in the pass the test column. There's a total of 19. How many total students are in the class? How many total students took the test? Are there? 27 total students. Okay, so remember, probability is the favorable outcome over the total possible. So 19 out of 27. That's the probability that if you picked a student at random out of the 27, okay, that they pass the test. Okay, now that is approximately, remember your little squiggle equal sign means approximately. If you were to divide that, I could round it, be 0.737 as a percent. You move that 2 places, that's about 70%, 70.37%. Okay, now again, that's approximately, not exactly. Exactly is the fraction. Approximately is this decimal or percent. Okay, so if you want to notate that to help you, label that as exact and label these as approximately or about. What's the probability that a student selected at random completed the homework? So there's 27 students. We want to know how many completed the homework. So that is this top row. Completed the homework, 22. 22 total students completed the homework. So that's 22 out of 27. That is the exact answer. If we were to divide that, 22 out of 27, we get 0.8148, and that's if I'm rounding, which would be approximately 81.48%. So about 81% of the class did the homework and about 70% passed the test. Now they want to know what's the probability that a student who completed the homework failed the test. So now we're not going out of the total number of students. See up here, it said a student selected at random for these first two examples. Now it said a student who completed the homework. So we're only looking at the students who completed the homework. Okay, so how many students completed the homework did we say? 22, right? So out of those 22, what's the probability that they failed the test? So out of these 22, they failed the test, 5 of them. So there is a 5 out of 22 chance that a student who completed the homework failed the test. Okay, if you wanted to round that, it's 0.2273, which is about 22.73%. Forgot to box this one in. All right, what is the probability that a student who did not complete the homework, okay, a student who did not complete the homework, so looking at the table, did not complete the homework, there was only 5 of them, okay, so if you are out of those 5, what's the probability that they passed the test? Okay, so out of those, that row did not complete homework, 2 of them passed the test. So 2 out of 5 is our probability. Now, if you divide 2 out of 5, that is an exact decimal. So I'm not going to use a squiggle. I'm going to use an equals 0.4, which is 40%. So there's a 40% chance that a student who did not complete the homework passed the test. Okay. Now this is just asking the difference between selected at random versus a conditional probability. The conditional probability are these that I underlined up here. Okay, the condition is a student did not complete the homework. The condition here is a student who completed the homework. Okay, so we're finding a probability based on this condition being met. Okay, selected at random was like these first two examples. Okay, and so I'm going to make a note down here. Selected at random means there it is completely by chance who you select. There's no condition. Okay, it's completely by chance and it's with every item has equal chance. Okay, so if it's random, every item has equal chance at being selected. So every student in this example, so out of all 27 in the class, okay, that would be selected at random. Conditional probability is a probability of an occurrence, okay, or of an event, given that another event has already occurred. Okay, that's what I underlined up here. The event that already occurred was the student completed or did not complete the homework. Then we found the probability of pass or fail, given that they did the homework or given that they did not do the homework. Okay, that is conditional probability. Okay, it takes into account the influence of another event. Does that make sense? So there were two conditional probabilities, number 6 and 7, and two selected at random. How do y'all feel about probability? And I know that can be a little bit confusing, and it's been a while since you've done that since geometry. But that's why I wanted to cover it so close to the TSIA, so maybe it's fresh in your mind. So tomorrow when we come to class, you're going to have practice over this. So you'll keep these notes and use them tomorrow in our practice on Delta Math. And then if you finish that practice, you can use the extra time to do any of your missing practices for days 1 through 5.